Hello friends, welcome back to DKodeTree, and today let's solve LeetCode 237, delete node in a linked list. This problem is simple enough, but it can trip up a lot of people because of a few easy to miss details. That's why I decided to cover all those key points in this video so that you don't miss any of them. Suppose this is a linked list given and we have to delete the node having value equal to a given target. In general, when we want to delete any node in a linked list, we need access to its previous node. So, if we are given the head of a linked list, then we can simply take another pointer previous and point it at the head and then keep traversing the linked list from the head to reach the node just before our target. So this is the previous node of our target node. And then we update its next pointer to skip over the target node like this. That is, we just make previous.next to point to previous.next.next, which effectively breaks this link and forms this new one, resulting in the removal of the target node from the linked list. But in this problem, things are a bit different. We are not given the access of the first node or head, and we only have a pointer to the node that needs to be deleted. And since this is a singly linked list, there's no way to access its previous node to perform the normal deletion that we discussed just now. This means we cannot remove this node directly. So what can we do in this case? The trick is simple. Copy the value of the next node into the current node. So we will copy this value 6 here and then bypass or delete the next node, which we can easily do by updating the next pointer to next.next. This means we simply do node.value is equal to node.next.value, that is copying the next element, and then move the node.next to node.next.next. So now we don't have this link here. So this effectively removes the next node, making the current node take its place. But there is a catch. This solution only works if the given node is not the tail or last node, as we rely on its next node for this trick. Now it might come to your mind that in case if it's the tail node, say our pointer is given here, why not just make it null and get rid of it? But let me tell you, this will not work, and here's where many people get it wrong. The reason is setting the node pointer to null does not disconnect it from the linked list, because you still can't update the previous node's next pointer to null, as you cannot access it. So the original node's address is still stored in the previous node's next field. So the node stays at the same place in the list. And that's why this approach only works for non-tail nodes. And that's also why the problem constraints specify that the input will never include the tail node cases for this specific problem. Now let's discuss the complexity. Since this approach does not include any traversal, and both copying the value and updating the pointer are constant time operations, so this approach works in just O of one time. And because it doesn't use any extra space, so the space complexity is also constant, that is O of 1. Now let's discuss the garbage collection nuances. Note that in Python, we don't need to manually free the memory of the node being deleted. This is because once there are no references to a node, Python's automatic garbage collector frees the memory for us. However, if you are implementing this in a language that doesn't support automatic garbage collection, you would normally need to explicitly free the memory of the removed node. That said, in this problem, the description specifies that we don't need to worry about clearing the memory, but sometimes the interviewers may be interested in it. And for the code, I will simply move these two lines to my editor. We can see that this works fine and is accepted. My site DKodeTree.com mostly has Python solutions currently, but for this problem I have added multiple languages so you can see how garbage collection differs. Feel free to check it out, and I will be adding more multi-language solutions over time. Keep practicing, and I will see you in the next one.